Hi and welcome to this video on data visualization. So data visualization is just super broad, so it's really hard to do one single video on all of that. So it's more like an introduction, showing you some of the common tools that we are using, and all of those tools that are adapted to different type of data. I chose to show you very quickly three different ones. The first one is a tool which is called R, which is just a statistical programming language, and now it's much more. It started for statisticians, and now you can do basically about everything you want, from image analysis to you name it. It's there. And the great thing about it, it's totally free, and that's why I encourage you to use it, because even when you leave, let's say work, or you leave the university and you go and do something else, those different skills that you may have learned on that language are going to be very useful for you, because you can just use that in basically any environment. So that's the first tool, and we're going to brush through that for 5 minutes maybe. And before the next tool will be actually using or looking at, we're not going to use it, we're going to look at Tableau. Tableau is not a free or open source software, you have to pay for that, but for the time being, when you are a student, you can use it for free. So there is a free license for students, providing that you're using it in a course or for your research. So you just apply for it on the website, you just apply with your university email, and that's usually enough. They don't really ask for more questions. And you might be asked to show your student card or something like this. But it's not a big problem. And once you have this, you're going to see if it's a real cool tool. So what's the difference between YR and then this data visualization software? Well, the goals are very different. Let's say in R, it's more for yourself and for the scientists to create scientific data for the scientists. The second tool, Tableau, is more for the non-specialists, and if you want to create something with an interface which is easy to use, to explore the data, for anyone who is not a specialist to look at your data in an attractive way, I would recommend that you use this kind of software, because the data can speak for themselves, and it's easy for people to see through those graphics how to use it. So that's going to be the second point. And then the third one, we go back this time to science, and it's a bit of the two in that case. We're going to use Paraview. Paraview, it's very widely used visualization software for 2D data, 3D data. It's used for medical imagery. It's used also, let's say, in climate science. It's used in hydrodynamics. And I'm going to show you some data of waves that I created very quickly using an SPH, smooth particle hydrodynamic model, where you can see the wave and the wave moving as particles in the system. And you're going to see how easy it's actually to upload the VTK file, the results file, into Paraview, that then use different parameters, such as the velocity that you may have recorded, and it's the one we've recorded here, and how you can use that after that to create amazing visualization. So that's what it's going to be about. So when I'm talking to you, I'm watching at the same time the video that I recorded of those different setup, so that I can comment through those. And we're going to start with R, and here we go. So when we start with R, and what you can see in front of you is the console where you have a direct response. You can, of course, use a script file and run your script file. And in that case, I'm using RStudio. RStudio is actually really good because it gives you a very similar feel to the one to MATLAB, I would say. And you can see your variable and a lot of different data straight into the windows, instead of having just the code in front of you, which might be very useful for people who are not used to that. Personally, I love it. I think it's very useful. and I don't tend to remember all sorts of code line, like in that case here I'm setting up the working space with setWD. It's not even necessary to remember that, because you have actually a button you can press just to get that done. So here, what do we do? Like the first line was setWD. That's actually set up your working directory to the desktop, because that's where I put my data file. And the data I'm going to read today, it's a CSV file, so you can create that into Excel if you want to. And it's called a 0 round 2 millimeter point CSV. So this data set is actually a data set that I created from a photograph of different sediments, and then converted that into different variable for in a table, like the length, the size of the data, of the grain, these kind of things. And here what you can see is that I'm plotting the data using the plot function. So you can use the plot, then the data you want, and in that case, the data, I'm choosing the column area, so the area data in that table. So it's separated with a $sign, and I'm plotting first only the 1 to 100 first data. And then I'm going to showing you that you can change the colors from red, blue, and you can also change the visualization of those different points using the PCH values. So here, 16, 12, 13, I would let you explore those different elements on yourself, by yourself, and see how it goes. Now we look at the histogram. So the histogram, you see, there is nothing to just press hist and it creates the histogram for you. Just look at the frequency. You can see that the frequency here is not normalized. So if you want to have a frequency between 0 and 1, that's something that you need to do on top, but it's nothing complicated in R, of course. So the next plot here, it's a bar plot for bar plot data. And I'm plotting the perimeter here between 200 and 210. So we have 10 values here presented in the bar plot. So the bar plot is not the histogram, of course. It's just a straight representation of the data. It's of the value of the data. It's not the frequency of the data. So the next thing is bivariate data, and you can see the way I made that video. You have on the right side at the bottom the code rewritten again. It's because I thought that it might be a bit small for some of you with a small screen. You can see the point cloud this time between X and Y being plotted together. This corresponds to a scatter plot on MATLAB. And what we just did is to adjust the labels of the X and Y axis. So here I'm going to show you some other plots. So you can see that in the data on the right, I'm using the word landslide area for the labels. Those are actually obsolete, and you've just changed back to the grain size diameter. And what I did show you here is that when you choose pitch, and pitch you do 16 without the bracket, you're going to have actually a different results, like the small flags, which are ones actually, being plotted together. So make sure that you don't forget those when you create your data set. And if you want to plot more than one data set together, the plot will create a new instance of the graphics every time. So if you want to add points, you're going to add the function points, P-O-I-N-T-S, like we did here. You could also add lines the same way, and lines is also L-I-N-E-S. Once you have those points together and defined by your X, which is the data area, and the perimeter of the grain in Y, then you can add also trend lines, of course. And the way to add those trend lines is to, of course, define a model for the trend line first. And here, because the data is very close to a linear relation, we're going to use the LM format, which is a model, the linear model in R. So when you create your trend line, you're going to use something which is called an abline or abline. And when you create the abline here, we're not going to plot the data straight away. We're going to plot actually the function that creates that line, which is the LM function. So the LM function here is defined from the perimeter and then the area. You can see that the way of writing this is with the y data first, the perimeter, and then the area, the x. So the dependent variable will come first. It's like y equals something something of x. And the way of saying that it's y equals something is here by using the dash that looks like a bit like a curl, which is on the right side usually of your dashboard. So you should see it. Oh, it's not in there yet. So on the video there is a bit of a lag. You can see plot the different colors. Oh, it was coming earlier actually. So when you had the outline, you could see the small wavy dash in between. So the next thing I'm showing you is the fact that you can also choose different representation of the same data based on statistical value. So here we're using plot data area and perimeter pitch 16, and then defining the color with the area being superior to the median of the area data. So everything which is going to be superior to that is going to be in red, and everything lower is in black, like you can see on the graphic on the right side of the video. So once you have done that, we're going to go to Tableau. Tableau, as I was telling you, is a very different graphic software. So the first step was just to show you, well, what you can do very simply, how to plot your data when you have 2D or 1D data together for exploratory analysis for yourself and your presentation. And then if you want to go further and create something which is nice, you can reuse the same data set, of course. And one of the ways of doing this is to use the Tableau desktop. So I invite you to eventually get your own license. When I say license, it's free license, of course, and get it started like you will see on the video. And what I've done, instead of trying to go back to the video itself, is just to play the video that they have online. So I'm not doing that presentation. It's just the video presentation that you can see from the Tableau company. And exactly as you can see on the video, it's very easy. So basically you import your data into the software like you would drag an Excel file or a SQL database or anything. And once you have this in there, the software will recognize what type of data you have. And it will be able to tell you whether it's a date, whether it's a text, whether it's a geographic location. And based on that, it's going to, after that, show you and propose you different ways of showing and displaying your data and working with your data. And while you're doing it, the beauty of it is that you can interact with the different values, choose to display certain values instead of then all of them, which is just great actually. So you have those different examples, you can see different type of graphics here, and visually they are very attractive. So what is great about it as well is that it creates also dynamic files. So I invite you to go and have a look at the website of Tableau as well, because they have a gallery where you can actually interact with the data. So there are those visualization, those visuals, and you use those visuals to interact with the data. So it's much more interesting and intuitive for, let's say, if you're a student or if you have someone who's not a specialist in your field, to interact with the data. And that goes into your cell phone, that goes online, which is just perfect actually. And then the last thing is Paraview, which is an open source solution to visualize 2D and 3D data in engineering and science. you're going to see this is also very intuitive and straightforward, and there are plenty of tutorials. So that's why I'm not going to go through all the different details. Whatever you want to do with it, just like type in your favorite Google or whatever you want, Paraview and how to blah blah blah, and most of the time you're gonna get an explanation, which is just perfect. And you're gonna have a main window where you can see your different data file. And what we're gonna do is just start with the result of a simulation I did, and I separated the bounds, which are called the bound in the simulation, which are the parts that don't move or are fixed. And because it takes a lot of memory eventually to display all of those data, you can choose actually with the eye on the left to display or not the different data set. And then you can rotate the data around, or you can use the arrows that are on top of the screen to modify this. And you can see the data set here looks very much like a box because it's a box. It's a box where we're going to see rushing waves inside. So here I'm just rotating it, playing it with you playing it for you to see. And the next thing I'm doing is to add the data set inside the data set, which is the point cloud of the data. And you can see I have a color from red to orange. This is just the ID. And what I've done is to change the velocity to the magnitude. Because the velocity computation takes actually a lot of effort, very often you're going to see some bugs and the color are not going to appear. So what you do is to just actually modify some of the parameters, and that's going to refresh the memory, and you're going to see actually what you want to see. So here you can see the water wave in the box. It's a box of a few tens of meters. It's 8 by 8 by 16 meters. And after that, I'm deleting the box for you to just see the water. And you can see in the center the wave with the velocity in the center. And you can see the acceleration, the rush it's not acceleration, it's the higher velocity on the shoreline. And then I restart the animation and you can see the wave moving through the different points. Each point is a calculation or the result of a calculation, so there is no interpolation or anything else here. And what I'm doing is to change actually the way you visualize the data, how you can modify the sequence or the timeline. And here, because I have a lot of time step, it's the easiest way to look at it because it moves slowly enough for you to see. And I'm restarting afterward the video again. You can display surfaces, but you can also display points. You can see the change of the data into points. You can change the point size of your data as well. There is just like plenty to do, and you can see that in that video I'm trying to change the point size and I just can't see it changing. I'm wondering what's happening, but actually what's happening is because I didn't select the fluid. So on your left side you can see part fixed and part fluid. So if you want to see the changes, you need to actually select part fluid and apply those. And here we can't see anything. So I'm not going to redo the video, I just let you have a try at it. Just trust me on this. You just click on part fluid on your ribbon on the left, and using that you should be able actually to see the data. So I'm going to leave you with this, and there is 3 more minutes actually of the video. You can see the different elements, and I'm going to show how the ribbon on the left, you can save the data, you can export them. You can see you have the VRML files as well. So this is really cool because the VRML files mean that you can actually create a data file that you can visualize in 3D with any 3D glass that you may have. You know, the type that you use for the games, for instance. And you can also, of course, create videos the same way I've created this video, and that's what I'm showing next. I'm showing the video on the dashboard of the different particles moving up and